Um, okay, good evening. So, as you know, this series is always a collaboration between the Archaeological Society Malta and the Department of Classics and Archaeology at the University of Malta. And thanks go, as always, to the head of the department, Dr. Karen Serracino, and to Professor Nicholas Villa, our ASM Vice President, and a really good link with the department. This evening, Dr. Judith Gatt will be delivering the lecture, which is entitled Conquering the Sea, A Story of Ambition, Boulders, and Ashlar Blocks from Amathous. And I hope I have pronounced that correctly. First, I'll introduce Dr. Gatt and then turn the floor over to her. And we shall have some time at the end, hopefully, for questions. So Dr. Judith Gatt is a maritime archaeologist specializing in ancient submerged coastal heritage in the Eastern Mediterranean, and has recently been appointed lecturer in the Department of Classics and Archaeology at the University of Malta. She holds a joint PhD from Aix-Marseille University and the University of Cyprus, supported by the Honor Frost Foundation, where her research focused on the construction techniques of classical and Hellenistic harbour structures. She is also a certified scientific diver and has participated in international research projects and field surveys as an active member both on land and underwater in Cyprus, France, Greece, Italy, and Malta. So without further ado, over to you, Judith.
Thank you very much. Thank you very much for all being here today. It's really nice to see the room full of people. Even if I'm new to the community of archaeology on the island, it's nice to, through this event, to meet people from the same field, not only maritime, but also from land. So looking forward to meeting you after this lecture. So the title is a bit ambitious, like the title itself and the subject. And it's a very small part of my PhD research, which I hope, as you will see at the very end, I will continue hopefully to develop here in Malta. It's a story about conquering the sea. And when we talk about conquering the sea, many times we think about navigation, about how people cross to the oceans, how they manage to deal with the weather conditions of the sea in order to cross from land to land. But conquering the sea is also about establishing land in the sea. And one way of doing that is also by building harbor structures. And this is something we do also today. And I just give an example of a very Maltese context, very modern one, of the extension of Terminal 2 at the Malta Freeport in Birzabuja, where currently there is work ongoing of extending an existing harbor structure further into the sea. And I really enjoy looking at these photos because, as we will see, it very much gives us an impression of how things might have looked like also in antiquity when we look on what the archaeological record is telling us. So conquering the sea, that's why I chose to select this as a title for the presentation, because the construction of harbor structures is one way of basically conquering an environment which is not built, not formed in order to host humans, but in some way also to fight human activity. So by building harbor structures, it's one way of doing so. But before we go into the subject, I wanted to make sure that we are all on the same page. And I think words are very important in archaeology. That's how we communicate with each other. So just to make sure we all understand what I'm going to be saying in the next few minutes. So here are 4 terms: breakwater, quarry run, boulders, and ashlar blocks. So breakwater, to start with, I'm going to be mentioning a lot the word breakwater. Part of my research and research of other colleagues, of course, is what we define as a breakwater in antiquity. There are different types of breakwaters as part of the research of my PhD showed. But again, I won't get into detail because this is not the main focus of this presentation. But I want you to understand that there are different types of breakwaters, and ideally in archaeology we should name them in a very specific way in order to understand what is unique, what is innovative, what is a trend. Okay, And one type of structure I would like you to memorize until the very end of this presentation is what we call a horizontally composite breakwater. I'm very sorry, it's very small. I didn't think of providing a bigger picture. So basically what you see here is a concentration of rubble, okay, of boulders like these. And on the other side, on the leeward side, the side looking into the land, you have ashlar blocks, which is basically this, okay? So just, this is a very simple explanation. Keep this in mind. A horizontally composite breakwater, will come to it in a few slides. Now, quarry run is basically the waste from quarrying activity. So again, this is a very important material used not only in harbor construction, but in any major harbor, in any major construction project. So it's the waste from quarrying activity, or from basically the dressing of ashlar blocks like these, which I think the walls of this hotel have been built with ashlar blocks. And the boulders, if not concrete, boulders is huge stones that have not been worked, okay? And there are many ways of extracting them, either by human activity or by natural processes sometimes too. And I want you to imagine the breakwater of Njar in Gozo. So that what we see is boulders. That's the term that I'm going to be referring to. Having tried to clarify these terms that I'll be using, the big majority of my work is based on the principles of construction archaeology, which construction archaeology is something that clicks to the minds of archaeologists more on the terrestrial side, like temples, churches, etc., historical buildings. But this is something that we are applying also in harbor construction in order to document these structures and really understand the story and the people behind them. So I'll be mentioning two terms. One is construction process and one is construction technique. So construction process is basically all the steps included into the materialization of a structure. In this case, of a harbor structure, okay? So from the planning of the project up to its construction to its maintenance, this is a chain basically of steps. The construction technique is one step into this chain of process, okay? And this is where basically the construction technique is the moment when we have all the construction material in place, all the workers, the plan is there, and people start assembling and putting in together all the material in order to build the structure. Now, the thing that is important is to understand this distinction, because sometimes when we talk about construction process, it can mean a lot of things. It can mean also it can entail also the quarrying activity, for instance. That is something I'll be mentioning, but I would like to distinguish both of these definitions. Now, so before I go again into the subject, because again, it's a subject a bit far away from the Maltese context, so I don't consider that everyone is familiar with the context. The title said about Amathous, Cyprus. So it's a site on the island of Cyprus, further to the east of Malta. And this site is dated, one of its phases, when the harbor that we'll be discussing is dated to the Hellenistic period. For you, just an understanding to have in your mind, it's around 310 to 30 BCE we're talking about for the context of the island. And during this time, we have a massive change. So I don't know how many of you know about the history of the island, but we have the Cypriot polities, or the polis, or the Cypriot kingdoms, depending, there are different ways of addressing them. These are little city-states that each and one of them had its, let's say, independent government. We have to explain it in a very simplistic way. And once the Diadochi, which are the successors of Alexander the Great, so Alexander the Great, when he went further to the east to conquer the known world of that time, he had a bunch of friends, of generals with him, and once he died, they started fighting with each other of who would take over his empire, basically. And what happened on the island is Cyprus, because it's in a very good geographical position, was basically an object of dispute between the different successors of Alexander the Great. And this system of the different cities that we have collapsed gradually with the arrival of the Diadochi on the island, which means basically that we do not have any more a fragmented island. We have one island under one governance, okay? So before the Diadochi arrived, we had different polis. Everyone was doing their own thing. There was no real connection between all the polis. But once the Diadochi arrived, this collapsed. And this is something very important because it opened the doors to projects that before were never thought even possible. So one of the projects that we'll be seeing is basically the harbor of Amathous, which is linked exactly to this period. And an important person that I would like you to remember is Demetrios Poliorkitis, who is the son of Antigonos, who arrived between 306 and 294 BCE on the island, and that's when the harbor that we're going to be discussing happened. Okay, so I want you to understand that this project happened at a time of massive, important changes on the island. Now, let's get to the interesting part. So Amathous is it's a coastal city, a polis on the coastline of on the south central coastline of the island. And here, this is just a small map to give you a bit of a general, broad understanding before we dive into the sea. So here we have the Acropolis with the temple. We have the first inhabitation of this site from the 11th century BCE, but we know that this temple, etc., and the settlement itself was established somewhere around the 9th century BCE. The harbor that we're going to be looking at is today submerged below around 4 meters below current present sea level. Okay. Now, what the story of the city, I will not go into it. But of course, if you would like to ask me questions to clarify maybe some points that might come up, would be very happy to discuss that after the presentation. Now, because we're looking into the harbor, it's important for you to understand what happened before my research started, and because my research is heavily based also on what has been done before. So I was very lucky to be working on a site that has been worked by different teams, who all of them have generated a very important and interesting amount of data, which were of great use for this study. Without them, this would not have been possible for sure. So in the 80s, there was this huge wave in the Eastern Mediterranean, in Thassos, in Greece, in Alexandria, in Egypt, of excavating harbors. And one of the, let's say, the big names at that time, and it still is Jean-Yves Prère, who excavated for around 3 years the site, the harbor itself. And his work mainly focused on the south side of the harbor basin, which I will show you very soon. And then after many years, and just before I started the PhD, this publication came out and basically opened the doors to many questions, which, as you will see very soon, I tried to tackle partially in my research. And then while I was starting the PhD, there was this Interact project, which basically there was a funding of documenting with underwater photogrammetry and air photogrammetry the site for the first time. Because in the 80s, at the time, yes, they had an understanding of photogrammetry, but it was with the limits of the technology of the time. So this was the first time that an underwater photogrammetry was done of the site. And this not only provided data for my research, but also for opening the first underwater archaeological park on the island. So I invite you, if you ever go to Cyprus, visit the site. It's very interesting to look at. So, so this is just the background of what happened before my research came into the story. And this is the site. So when I'm talking about the south side of the harbor basin is basically this area here. So the harbor of the Hellenistic period that was built by Antigonos, Antigonos Gonatas, consists of 3 structures, but today I'll be talking about one, because again, I don't want anyone to be lost in this story of ambition. So we have 2 modes, one east and one west. And then we have this particular structure, which struck my interest. And that's why I think I went also into harbor construction techniques specifically for my PhD research. So having this site and having all this information and all this research happening before me doesn't come with any challenges to consider and limitations. And I would like to note them down because this has impacted the degree of hypothesis and analysis that I've provided and is currently basically in process of publication. So it's important that I'm transparent about what are the issues with the study of this site and specifically of this harbor structures that I will be talking about. So as I said earlier, the site was excavated in the 80s. So it was important to understand where people excavated, where stones were moved, because what I wanted to do is really understand the construction of a harbor structure. So I needed to understand if the structure we see today has been changed, has been altered, or it remains as it was. And of course, it has moved for natural reasons, but not by human. And what I could see from the archival study and the publication is that we have what the French called sondage, and it's part also of the publication. So that's why I kept the term sondage and not trench, so that if somebody reads the publication, understands what I'm talking about. And we see that actually they excavated in the structure. And here is a photo from the archives of the École Française d'Athènes, where we see that they opened trenches inside the harbor structure. So some areas were basically altered by human activity. So it was important to consider them as an X of including them into the interpretation. And of course, there was an issue with the aerial photo. So the aerial photo you see here, it's very important to note that I was very, very lucky to be working with a team from the Technical University of Cyprus who have a laboratory and they do correction of the water refraction. Because when you have aerial photos of an underwater site, basically when you start taking dimensions, there's an error. The measurements will not be correct. So with AI, basically, I'm not part of that process, so I'm not the person to understand of how exactly they managed to do it. They lowered the percentage of error. And so that's why we could basically start taking measurements from this aerial photo. Otherwise, we would not have been doing that. Because as I said earlier, yes, there were underwater photogrammetry of the site, but the breakwater, which I'll be talking, was not covered entirely by underwater photogrammetry. So it was very important that I could work with an aerial photo that was giving me at least a good understanding of measurements with plus and minus error that was acceptable. And of course, the difficulty of measuring surfaces, because even though I was able to visit the site and dive and snorkel, it was not possible always to have a systematic way of measuring the surfaces. So what I ended up doing was basically a desk-based measurement of the whole stones, of the boulders specifically, and trying to take the longest, basically visible length of the material. Again, I know it's very boring, but I want to be honest with you of what I did and what I did not do. Now, how was it possible to bring the data that existed before, the challenges that I mentioned, through the methodology that was applied? And again, this is important to explain. So in order to understand to which extent this could go, basically, this research. So first of all, there was an architectural and topographical documentation of not only the structure I will be discussing tonight, but of all the visible ones that were not especially documented by the French in the 80s, but I think that's a presentation for another time. But the fact that we were able to go with a total station and do a proper documentation really provided us with more data on the structure I'll be talking about. Then, of course, we had the data from the Undercut project from 2022, and archival research, which came from the excavation of the 80s, but also archival research from the ports authorities of the island, which gave information about harbors on the island and how they were built in much, let's say, earlier periods from the 30s to the 50s. And all of this was inserted in a GIS database that provided us a very concrete understanding of what information we have, what information we need to get in the future, etc. and of course to take measurements and do the calculations I'll be showing you in the coming slide. So let's go to the interesting part. So I've been mentioning this breakwater, and I asked you to memorize the word south horizontally composite breakwater. I know it's very long, but I like to be precise, rather fancy, so that everybody gets the point. So this is a very beautiful drawing done by Jean-Yves Ferrer and Tony Kodzel, the architect of the excavation of Amathous in the 80s. And they published this sketch, which is not to scale. And when I saw it in the 2017 publication, I was like, interesting. I've never seen that in the archaeological record. And basically, they describe the structure into three pieces. The breakwater, which is the boulders that I mentioned earlier. And here I just give you an idea. This is a 1 meter scale, so you can imagine the size that we're talking of stones. Then they mentioned the debris, which is somewhere here in the middle of the structure. This is an image that I took. So you understand it's very small stones that you can grab with your hand. And then you have the mole, which is now you don't see them very nicely dressed blocks, but they were. It's just of the vegetation and in a marine environment that eroded the blocks. So there are three basically sections in the structure, and this is very important to keep that in mind. So this is the structure again of where it is located. Now, this is a sketch I did with my brother, who happens to be an architect, and I enjoyed working with him because he had a different understanding of construction than an archaeologist, so it was a very interesting collaboration. And when we drew this together, I went around and started talking with engineers, with harbor engineers, not harbor engineers of antiquity, present harbor engineers. And I think this is an important thing to do because it gives you an understanding of things that I myself, as a non-engineer, have no idea of these concepts and of the environment. Of course, it is risky because once you start talking with people with modern perception, sometimes you get influenced as someone understanding antiquity from a modern perception. But I still think it is important to have that discussion, even if it was conducted in an informal way. And once I was showing them this sketch, basically, of how the structure looked like according to the 80s excavation, all of them repeatedly, 3 different harbor engineers I've consulted, told me this structure would have had a very different preservation that it has today if it was built in this way. And why? Because based on their hypothesis, the structure today would have looked something like this, meaning that you would have the mole partially collapsed, you would have boulders inside the harbor basin. So basically, probably the collapse would be inwards, not seawards, if that is clear to you. So here you have to imagine this is the interior part of the harbor basin, and this is where your open sea, outside to the open sea. If you've had a structure where the interior part, where the debris is, where the quarry stone that I mentioned earlier is exposed, you have to imagine with a storm, with a wave, this is very easy to collapse. So it started with a simple hypothesis, okay? But I said, okay, why not explore this lead? Why try to make sense of what these people are telling me, if possible? So again, we go to these 3 categories. And this is important because it's not a wrong way that they presented it. It's a very correct way, and they did a great job. But probably this is not the way it looked like. So that is where we started. So I will try to take you on the 3 different sections of the structure, from the what they call the mole, where the Ashlar blocks are, and slowly up to the breakwater, and try to understand what the archaeology tells us in collaboration with what harbor engineering can tell us today. So starting from where the blocks are, so here you have to see a line of Ashlar blocks. This line, it's not that it seems to be interrupted, but believe me, it is not. It's just that the Posidonia is covering everything, so you don't really clearly see the line. And because the Posidonia is a preserved, it's a protected species, we are not allowed to clear it. So I couldn't draw here the Ashlar blocks. So what you see is what is visible and what I can draw. Otherwise, I just left it empty. And it is around 174 meters long, so it's huge. And you have stones, ashlar blocks, which are, you have only one row. This is impressive. And your maximum width is 3.5 meters. So it means the maximum length of a block, because this is one row, is around 3.5 meters. So it's huge, these blocks of stones. And these were placed for 170 meters underwater. So try and think of how that was physically possible for such a huge distance. And from the calculations that we were able to do, we have around 1,300 blocks that were approximately placed underwater. One thing that I want you to keep in mind, and you will see in the very end, is these little, I don't know, sketches, I will call them right now, but these are lifting bosses, which you can see here a little bit, and here too. We'll come back to them. These are ways of basically lifting ashlar blocks, but it's an important key to keep in mind because it will be part of this ambitious project. Along this row of ashlar blocks, an interesting thing came up, which was not discussed, but rereading the publication was kind of made a click in my mind. Along the mole where they excavated, and by the way, they didn't excavate the entire mole, they excavated sections. So this is where the sondages are, where you see in white. So these are the areas where they excavated. And where they excavated, they found nails. And these nails were not discussed of what was the role in the harbor basin right next to the structure. It was just left undiscussed. And so keep that in mind. We'll get back to it very soon. Now, the moles are the part where you have the ashlar blocks here. I think it's very clear. You have one row around 174 meters, and then we have the debris and the boulders. Okay. Now, what we did with the aerial photo that we had, we retraced every single stone that was visible on the aerial photo, or on the aerial photo. And based on, while retracing, we took measurement of the maximum surface that was possible. And this gave us a categorization of different sizes of stones we had mapped on the structure. And this was important in order to understand where is each size of stone on the structure. So it was very, very frustrating to do this part of work, but I think in the end it paid off because it gave us a much more clear understanding of how the layers of the structures are currently preserved on the site. So it is important to remember that here it's the site that we were not including. So I didn't go into mapping because it's an area excavated. So the whatever you see in pink, between 0, 50 and 1 meter is this kind of size. And same for here between 1 and 2. So you see the different sizes of the stones basically on this map. And wherever you see this yellowish is material that is around less than 15 centimeters. So we're talking about much smaller, much manageable pieces of stones, which correspond to the debris that I was discussing earlier. So basically this map is a very good understanding of how all this material is dispersed along the structure. As you can see, there is the nice Posidonia, so a big part of the structure is not visible, but at least we had to do something. Otherwise, we would just have left it there and say, well, I can't do anything with the Posidonia. But it's, again, part of the limitations that we have to accept. Now, having mapped these, the second step was to really understand the profile of the structure. So yes, we can use QGIS and with the terrain tool plugin do sections. And this was very naively said, and I did the sections, and they produced these sections here, which initially I found that they were impressive, because you have here the row of headers, the ashlar blocks I was mentioning, the single row of 174 meters, and then you have here basically this gap, which seems to correspond to the debris, and then you have here the boulders. But once visiting the site, you understand that this might not be actually the reality. So when we went back in 2023 to do the field work, what we did was a proper section with a total station. And why? Because the terrain tool was basically considering also the Posidonia, the upper part of the Posidonia, not the lower part. So what we were seeing was an erroneous understanding of the structure. But with the pole of the total station, I know if there's a marine biologist, they will kill me, but you could go inside further, closer to the roots of the Posidonia and have a much more clear understanding of the elevation of the structure instead of the upper part of the Posidonia, which, as you might know, Posidonia can grow for centimeters to meters sometimes. So it was important to try and get a very good understanding of the profile. And what I selected was the area which had less Posidonia, so we could have a much more clear understanding of actually what the material is. And so what you can see here, I know this is not very fancy, but it's correct when it comes to documentation. You have here the Ashlar blocks that I was mentioning of the part of the 174 meters again. And then we took basically points going up outside to the sea until it ends, basically. And what we see is collapse seaward. Instead of going inside the harbor basin, the collapse is seaward. And why we are for sure that the collapse didn't happen inside is because when they excavated the harbor basin, they didn't find any boulders, any ashlar blocks, nothing, which is impressive. So this part of the mold that I was telling you with the ashlar blocks was pristinely almost preserved, if they found a very few ashlar blocks falling into the harbor basin. So what we came up as a hypothesis for the harbor structure was that basically we have here again this row of ashlar blocks, and we have basically a structure with different layers, not separate layers, but layers one on top of the other. So we have a layer here of the debris that Emperor described, the quarry run. We have a layer which is of medium-sized stones, boulders, which is around from 50 to 1. And then you have the huge ones which go from 1 to 2 or to even 3 meters. And this is something that when I showed again to the engineers made sense. The fact that you have a layered structure, all these sizes of stones on top of each other. And this explains also why we have a seaward collapse of the structure and not collapse inside the harbor basin. So you have basically imagining that once with time and storm and lack of maintenance of the structure, slowly, the boulders collapse. And then the medium-sized boulders collapse, and then the quarry run collapsed. And here you go, you have a structure with around 60 meters of width. Currently, this structure has around 60 meters of width. It's not the initial width, but it is part of the width that currently is preserved due to this collapse. Now, so just to explain to you here, again, this is the core, what we call in harbor construction today. Then you have the, let's say, the intermediate layer, and then, let's say, the big protective layer, which breaks the first contact with the waves. And this is something that we use today in harbor construction all the time. Otherwise, we would not have had harbor structures that are functioning and long-standing inside the sea. And it would make sense that such a construction happened, because otherwise we would not have had a structure in such a pristine level of preservation. So coming now into this ambitious conquering of the sea. So we went into looking into the structure again, understanding how all this material basically is in contact with each other. And the nails were a big part of this ambitious story, because we have a huge gap in our understanding of how did people manage to build such huge harbor structure in the open sea, because this is a linear coastline, okay? There is no promontory or reef protecting whatever construction. So these people went right into the sea and they built such a construction with no whatsoever protection from the natural environment of the sea. So once we start seeing the nails that appeared in every basically trench that they opened, we start to making questions of how they could be linked with harbor construction. So that is where, when we look into the archive of harbor construction, not from very far, not from very long time ago, this is the construction of a harbor, which is a few kilometers away from Amathous. So this is Limassol. If you've ever been to Cyprus, you definitely have visited Limassol. And then there is Amathous here. So it's a few kilometers away. And this harbor was built in the 50s. And from the photos that we could see, the structure that we see here is very similar to how we hypothesized that the breakwater was built in Amathous. So if I have to go back, so basically the way you see here, you have a platform where people can circulate, and then you have this rubble kind of construction. Same here, you have the rubble here, and then you have this platform. So immediately, once I had that hypothesis and saw these photos, I was like, wait, what this can show us, what this can teach us. And we can see this barrier right here, which is of metal, of course. But from what I was talking with engineers, they use some kind of clamps, basically, to keep the metal barriers together. So when seeing, basically, the nails, one first idea that came into mind is maybe they've built some kind of wooden barrier, including using nails, in order to create a protective environment so that they can start building their ashlar blocks, which are all in such a nice linear way placed underwater. And this is something, when you look into the bigger picture of what we see in harbor construction, wooden barriers or cofferdams, as we call them, is something that we see all the time in the Roman period. So it's no shock. Of course, you tell me, Judith, this is the Hellenistic period. But what tells us that the Romans came up with this idea and it had not another way that it functioned? Of course, not with concrete, but with ashlar blocks. So it is a possibility that while they were building this very linear and long structure with such huge stones, they might have used a barrier in order to make sure that either they follow a straight line or to keep the main waves outside from their process of construction. Now, of course, some might tell you wooden barriers, they will not last, they will collapse. Fortunately, I didn't put a photo, but also when they were building the harbor of Limassol, this barrier, the metal one, collapsed. But then after a few months, they went again and they built it up again. So even if it didn't stand all the conditions in a marine environment, they still use this method. So it would not say no to the fact that they would have been using a wooden barrier, even though it would not be successful all the time. So again, trying to think and imagine people working in these conditions and going to the extra mile in order to make sure that the environment is safe enough to build such construction is part of an ambitious project. But then when we go further and look into more the technical part of how did they move all these ashlar blocks and all these boulders to the site and place them underwater. And this again is something that we really do not have an answer for in harbor construction, especially for this period. So I would like to start with the ashlar blocks that I mentioned earlier. And remember the part I was telling you, lifting bosses, to remember. So in Amathous, we have 1, 2, 3, 4, 5, 6, 7 types of lifting bosses. And this is unique. This has never been found in any underwater construction. Now, if you go on the terrestrial part, you will see a variety, of course, but underwater construction, this has never been found, this huge variety. There is, of course, in Syria and Arwad, the lifting boss is used, but there's usually one type being used, not this kind of variety. So we can imagine different kinds of machinery, and this is the machinery that was proposed by Tony Kozio, the architect, because simply we do not have any archaeological evidence. We base basically on historical evidence and on ancient writers. And using Aaron of Alexandria, he was able to propose this kind of model of how these ashlar blocks were placed underwater with the use of the lifting bosses. However, it does not answer our question why we have 7 types. But then we'll go further into the next slides to get that maybe an answer for it. So the ashlar blocks, we can maybe imagine how it was possible, okay? But when we go into the boulders, it is very difficult to understand how that happened. I mean, first of all, to transport them from land to a barge, okay? And then from a barge underwater in a controlled environment, that's another story. Now, again, we do not have any any evidence whatsoever. We know from Pliny the Younger, when he describes the construction of a harbor, where he mentions big boulders being used and a barge, the presence of a barge. Now, how exactly it worked, nobody knows, but we have a very great architect, Jean-Claude Golvin, who really likes reading ancient sources and recreating them. And this is a proposition of how a breakwater could have been built in antiquity. So we can imagine barges and this kind of machinery going along the structure in order to materialize it. So again, you have to imagine multiple things happening at the same time, which is a part of an ambitious project. Now, how and from where did they get this material? It's another part of the question. And as you can understand, I'm going backwards in the construction process. So from the structure, going back into how it all started from the material itself. So if you read the publication, which I highly encourage you to do so, they suggest that the coastal quarries and the quarries inland have been used for the construction of the harbor, which is a great theory. It's very interesting. And I was lucky enough, while I was doing the PhD, there was a postdoc happening by Luigi Germinario, who was sampling the stones from Amathous harbor. And we were able to see what kind of stone it was. And the general, let's say, understanding is limestone. But once you understand what kind of stone is from the coastal quarries, you see that it's not the same kind of limestone. It's sandstone. So it's not these were not used for the boulders or for the ashlar blocks. So probably it was coming from further inland, one, or maybe also using other sources. Because again, you have to think something that I didn't say actually earlier. The calculation of the material used, I said earlier, around 1,300 ashlar blocks. And when it comes to the boulders, we are around 21,000 cubic meters of material. So you have to imagine 8 Olympic swimming pools. So it's huge, the amount of material being used, calculated for this construction. So did it all come from here? I mean, I doubt it, to be honest. So it's good to keep in mind that at a time when there was a massive change on the island politically, Antigonos Gonatas, one of the successors, decided that they will go all out and build a harbor specifically on this part of the coastline of the island. Now, you can tell me, Judith, so what is ambitious about it? Okay, I talked about the size, about the difficulty, but we have to also understand that this type of structure, the horizontally composite breakwater that I described earlier, is unique at its time. In the archaeological record, we do not have any kind of structure that is similar to it. However, when we go in later periods, we start seeing it appear in different forms and with different materials. So here I'm giving the example of Caesaria Maritima, the outer part of the harbor, where, again, unfortunately, we do not have any documentation, but reconstructions. But based on what they found, basically they had an ashlar wall. So remember that row of blocks, basically. And then they placed concrete blocks. They filled in the middle with whatever they had. And then they placed basically boulders and rubble, whatever they had. And this created a very similar structure that we see in Amathous a couple of 100 years earlier. Of course, with concrete this time being used. In Amathous, we didn't have concrete at that time. And this is here in Crete, in Chersonissos, where again, we see a row of ashlar blocks with concrete, again, being used because this is Roman, and boulders on the outer side. So this is something that we see happening later on in the Roman period. But in the Hellenistic times, this seems to be a unique example of its time. And even in the classical period, we do not have such an example, or neither in the archaic. So I gave you some hints of why this is ambitious. It's ambitious because it happened throughout a time where we do not have a politically stable island, if we have to put it that way. But usually during these times also the big booms happen. A project which needed a lot of material, which probably also might not have not only been local, but that is something to look into. A size and an environment which was not very user-friendly, if we have to use that word. But then we have to think about also beyond the ambition of the person who came up with this project to build a harbor in order to have a safe basin for his naval fleet. We have to think also about the people that were involved in this construction. And this is something that unfortunately I was not very comfortable into delving deep, but I think this is something that I would really like to explore in Malta. And I'm giving you here a small example. I live in Birzabuja, and I frequently like to walk along the coastline. And I've seen people currently working on the construction of the quay in Birzabuja. And of course, I like to sit there, talk with them. I, of course, took their permission to take the photos and to show them tonight in this presentation. But what you see these people doing and what they go through is extremely interesting. And one specific thing that one of the divers told me is that, you know, these engineers, they come with plans, but they don't know what it means to be underwater and to do the actual work. And actually, this is something that made me question of how then did the people of the workers, the builders in Amathous manage to build the harbor of Amathous when an engineer or an architect came over with a plan. So remember when I told you about the lifting bosses that I mentioned earlier and the 7 types? So this is a plan that one of my colleagues, Vasilis Papadakis, made based on the publication of Amperer of the harbor. And he tried basically to map all the different types. So where you see, for instance, this corresponds to one specific lifting boss type, okay? And we see that all of this is super messy. Like there's no coherence, like one lifting boss is next to another. There's no pattern whatsoever. So once we started looking at the chaotic kind of understanding of this placement and the use of lifting bosses, we try to look at the bigger picture. So how does this is represented in the entire Ashlar's construction? So when we looked also at the west mole, the east mole, and the south horizontally composite breakwater, we saw a pattern that initially they all started with using only 2 types of lifting bosses. And as soon as they started towards the entrance, which is considered to be the last part they worked at, because it's the one that was the least exposed, the main exposed area for the main winds was this one, basically. The amount of and the variety of lifting bosses increased. So maybe what we see here is once the project started, the people were very ambitious. They said, yeah, we have 2 quarries, they will get the material that we need. But then when it comes to reality, they understood that, hey, if we need to finish this project on time, because Ptolemy in Egypt is getting very pissed off because Antigonos is here, and I really need to protect my fleet, we need to go fast. So they recruited other people. And the lifting bosses, it's not unusual in construction that they might represent different quarry groups. Okay, so it might explain why we have 7 types and not 1 or 2. So imagine one group, they decided that they will do 1 type of lifting boss so that the boss knows that they quarried 4 and not 10 blocks, so they can have their proper payment that day. The other thing also to note is that this did not only facilitate the payment, the logistics of the project, but it also facilitated the moving of the Ashlar blocks. So imagine blocks that we're talking about 3.5 meters long, we're talking about maximum, sometimes also 4 tons, so it's huge, how they were going to be lifted. So if you put a rope in the middle of the stone, probably it's going to crack. So ideally you put stones on 2 sides and not in the middle to hang, to basically move around the stone. So what I want to come up in here, when we look into ambitious projects, sometimes it's good to look into where we can find the people. And from this very small example of little lifting bosses, we can at least try to imagine that we have at least 7 groups of individuals, groups of people that were working on this project. And another thing to consider is that this is not at all familiar in Cyprus. Lifting bosses are almost very rare on the island. So we have to think of probably people coming over from either abroad, from other places of the Eastern Mediterranean, or knowledge of individuals coming over and teaching the locals of how they should extract the block. So we have people meeting from different areas and exchanging knowledge. So again, this is a small way of basically closing this presentation, of keeping in mind it's not only about the ambition, but it's also about the people and how we can look for these people inside the archaeological record. So I would like to finish by thanking many institutions that supported either financially, either through research, this research in the field, but also the PhD. It would not have been possible. And I would also like to thank you for being present today and hearing about this. And I'm looking forward to any questions or discussion. Thank you very much.
Very, very much, Judith. That was really interesting. Something I have never really considered myself, never thought about. And so you taught me a lot this evening. That's great. Any questions? That possible? There we are.
Talk about the Ashlar blocks.
Yes.
How many courses there? So consistent.
Okay, so the maximum number of courses in the south horizontally composite breakwater is 6. Sometimes we find 4, because I have to mention that there is this hypothesis that there might have been use of the stones of the harbor of Amathous during the construction of the Suez Canal. They came, they lifted stones. Again, this has never been found in records. There was research, but it is something that we know that there was a lot of use of building material in Amathous in the terrestrial site. We know that from 18th, 19th century happening. So why not use also material in the sea? That was something that we know that the British did, for instance, in one of the other coastal sites in Salamis, that then they use it to construct the modern harbor of Larnaca, for instance. So it's not impossible that's why we see missing Ashlar blocks and not always 6 courses.
Following any question, the courses where they buried, did the sondage go down?
Yes. So the thing is that part of the study was to see how the excavation impacted the sites. So they went down pretty like to 2 to 4 even meters sometimes, and the quarry and the structure was visible only the first course of the structure. So only 1 Ashlar block was visible, and they went down to find the other 5 basically. So it's huge. And now the thing is different, because after they finished excavation, there was an order from the Department of Antiquities at that time that they should not refill and they leave exposed the structure, because they wanted to open at that time an archaeological site for the public. It never happened. And unfortunately, with storms, a lot of the courses collapsed. So we see collapse not because of the activity of the harbor structure itself or because of storms. It was mainly because exposing it with excavation and not protecting it made it collapse in reality. So yeah, I don't know if I answered your question. Yes.
What's the reconstructed height of the walking surface above the water at the time in the Hellenistic era?
Okay, so that's a great question, but I unfortunately will have to tell that we do not have, for 2 reasons. One, because again, we have this problem of not knowing exactly what material has gone, either with activity of people reusing material. And the second thing is because we do not have a clear understanding of relative sea level change in the area. So there has been a study of beach rock in Amathous, which I was part of. And one of the estimations is that in the Hellenistic period, apparently the sea level was very close to the present one, meaning that we do not have any change actually. So you tell me why, Judith, then the structure is below 4 meters, the lowest part. One of the other things to consider is not only the change in sea level, but this is a huge structure built on sediment, which is very clayish. So it's very easy when you have such heavy stones for the structure to sink. And then also thing that I didn't mention is that we do not have any foundation layer. So there's no consolidation of this clayish layer. So immediately once they place the Ashlar block, slowly, we have a process of compaction and consolidation through time. So we do not have a clear reconstruction. There is a reconstruction provided by Pierre Aupert in 2020. But again, it's purely hypothetical because we do not know exactly how deep the structure has sank into the sediment, exactly how was the sea level, because the sea level I mentioned earlier is based only on the proxy of beach rock. So we do not have any other coring, for instance, that gives us another second evidence to enhance this theory. So yeah, so far we do not really have an understanding, unfortunately.
And is on the uppermost layer of preserved stone of
Mhm.
ashlars, where you have the full stack, if you
Mhm.
think that's the case, is that dressed differently than the surfaces of the lower courses? To
Mm.
suggest
Mm,
it's a finished surface.
no, they are all of them are perfectly, I mean, you saw photos, which they don't seem very nicely, but it's simply because of the erosion has been super aggressive on the stone. There's been marine biologists working on it, and they saw basically that the Posidonia has been eating the stone, basically the roots of it. Eating, it's not eating, but that's a way of putting it, eroding the stone. So that's we do not see a difference. One thing that in the 80s they saw was the traces of clamps connecting the stones. And for some, this is an indicator that, here we are at the sea level or above sea level, because the clamps ideally, was either with wood, the connection, or with lead and metal. The thing is that if we consider that we have wooden barriers, cofferdams, we know that at the time we have technology of pumps to remove water, so they could have placed clamps underwater, but removing the seawater inside the cofferdam would basically create an environment where it was possible to place clamps underwater in reality. So that is the only hint that we have. But the thing is, once we went back in 2022, because there was a Posidonia growth, we couldn't identify these traces of clamps nowhere to be seen. So it's not sure where exactly we have been located. So it remained more of a thing that we can't really confirm currently on where they were. Yes.
So as you said, it was a very ambitious project.
Mm-hmm.
I was wondering whether you came across specific context that justifies such a level of ambition, and also are the conditions, the maritime conditions in the south of Cyprus so bad that justify that thing, and couldn't they find, like, if the point was not upward in the south, right?
Mm-hmm.
They couldn't have found like a natural geographic context that allows them not to use 8 Olympic pools of
Okay, a very good question. So, because I didn't want to go into the detail of the context, but it's very important. So thank you for bringing that up. First of all, during this time in the Eastern Mediterranean, we have a lot of harbor construction or repairs or maintenance of harbors along the Eastern Mediterranean. So it's not the only harbor that was built or maintained during this time by the successors. And it was something important for them to do, because you have to imagine this a time where people were gambling basically their future. So they wanted in some way to secure their strengths, their forces, their naval forces. So they were investing highly in triremes and in naval bases. And that's why they were building these kind of harbors such as Amathous. So first of all, that is the first context. Now, the problem in Cyprus is that why it is ambitious, that the south coastline is very straight, linear, the coastline. Now, you will tell me, yes, there are some spaces where you have some coves, but you have to understand that at the same time, some Cypriot polities were under the influence of another successor. So they couldn't go and build wherever they wanted on the island. And the reason why they chose the south of the island, primarily, they built also on the north, but the main focus was the south, it's because it was closer to Alexandria. So for Ptolemy, who was based in Alexandria, he needed a naval base in Cyprus. So he chose Paphos, which is a city. I think I can go here just to show you. Yes. So Paphos is here. So Ptolemy invested in a harbor here. That's the hypothesis. That's another story. And Amathous is here. Now you can tell me, Judith, why didn't they build here? Because here we do not have, at least for now, an understanding of any prevalent successor fighting for the influence on top of a Cypriot polity. So here, for instance, in Amathous, we know that Antigonos really had an influence on the locals, and then Ptolemy again, and there was this interchange between them. So it was basically they decided where to build the harbor based where the influence was in reality, if that makes sense to you. Now it is ambitious because, of course, before the successors arrived on the island, the Cypriot polities had harbors, but they did not have harbors of that scale. They were very highly using natural features instead of going into the open sea and building harbors in a way with no whatsoever natural protection. I don't know if that answers your question. But it's very important, your question. I wanted to put, but I said I want to go as much straight to the point without going into the generic understanding. But when I was trying to understand why they built this structure, it's very important to consider that parameter of like what was happening around the island and in the island, and why Amathous was chosen and not another site, for instance. Other sites nearby, like Kition, for instance, we have a naval base, and we know that Antigonos had invested in the repair, because we had a harbor before the Antigonids arrived on the island in the classical period, and we know that they invested in further in for the ship sheds. So there were things happening. They just wanted to have a second military base close to Alexandria so that they can attack if Ptolemy was coming for Cyprus. That's the whole idea behind.
Is there any evidence for slipways or ship shed?
In Amathous?
Yeah.
It's a very hot topic. So basically, to give you the a bit of an understanding. So you see here, I didn't discuss it, but again, thank you for bringing that up. In the publication, there is the interior basin. Now, this interior basin is a big question mark, in my opinion, simply because we do not have enough evidence to say that that is an interior basin. For sure, it was a bay at some point, this area here, because we have cores that indicate a clayish environment, etc. But unfortunately, these cores were never dated. So we do not know exactly when this environment corresponds. And we know that this area probably was silted once there was some kind of activity happening here, some kind of obstacle being created, which is the harbor here. Now, this area was excavated by the French school at Athens. They found a structure which they consider it might be a slipway, but if you have to imagine a slipway, which is this, they basically excavate only this part. So it's a very small part. So their theory is very not very convincing at the moment. They tried to get the permit to continue. Unfortunately, it didn't happen. So hopefully in the future, they will continue to excavate in that area. But there is the possibility that there must have been some kind of a slipway in that area.
Another question very quickly. Not because I have
No.
yeah.
No.
Don't need us folks. You don't want to go. Is there anything Phoenician with the slipways at Kition?
Oh.
Because you mentioned Kition, and therefore I wasn't going to ask, but since you mentioned it.
Okay, this is a very good thing that you asked, because it's something I really liked. I kind of came before I started the PhD on this topic about what is Phoenician and what is Greek, and especially in Cyprus, a hot topic, because how do I identify in construction what is Greek and what is Phoenician? When you see especially the bigger picture, when it comes to construction techniques, you see the same construction in today Syria or Lebanon in Greece, and vice versa. So when it comes to construction, unfortunately, it's very risky to go onto that road. It's not because we should not acknowledge who did what, but in terms of construction, it's very fluid, especially when we talk about harbor construction techniques that are Phoenician or Greek, because the Phoenician, we say it's rock cut, as if the Greeks never did rock cut. Actually, they did rock cut, the Greeks. So it's not purely of a specific group. So again, in the slipways of Kition, there has been so far no discussion whatsoever of any Phoenician influence in the construction of the slipway. Of course, we know that the Phoenicians were there, but on the construction whatsoever, no, as far as I know.
Okay, well, thank you very, very much.
Thank you.
Again,